What is the most used man-made material on Earth? You guessed it, concrete. Look around, it's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. All right, everyone. Welcome to another episode of the Concrete Logic podcast. Today, I got Bob Banka with the Concrete Management Solutions. Bob, if you could tell us a little bit about yourself today, and then we'll get into Pervious Concrete.
Cool beans. Okay, thanks. And thanks for having me. As you said, my name is Bob Banka, President of Concrete Management Solutions. We are a consulting firm working with ready-mix producers and contractors, very heavily invested in the pervious concrete market. And we do other things, mixed designs and plant evaluations, driver training, batchman training. But what I really enjoy the most is dealing with people and teaching, spreading the word about pervious concrete, which may be the greatest product since sliced bread.
Yeah. So we were talking a little bit before we hit record. For folks that don't know what pervious concrete is, could you share, like, if you were telling someone what pervious concrete is, how would you explain it?
We consider it's a stormwater management tool. And the way we look at it is that before we paved over paradise with asphalt and or concrete, when it rains, Mother Nature wants that rain to get back into the ground. It recharges aquifers. It filters the water. It's just environmentally friendly for us to do that. So rather than putting concrete on the ground, we can make parking lots or sidewalks or driveways out of pervious concrete. At its basic, if you just, how do you make the most basic concrete mix for pervious? You just take the sand out of it. Then you're gluing together the stones with the cement matrix to create a product that will hold together. We used to always say it looked like a Rice Krispie bar.
Mm-hmm. That's what I thought when I saw it.
That gives people the idea of what it is. If you pour water through a Rice Krispie bar, we can do the same thing. But we can offer a solution to be able to still use your valuable land, because God's not making any more of that. So we can build and have parking lots. It really catches people's attention, say down in Florida, where every year we see on the news 2, 3, 4, 5 homes that get swallowed up by sinkholes. And the problem is, if you travel down to Florida, there are retention ponds everywhere. There's concrete parking lots, asphalt parking lots, and big, huge retention ponds. Well, that's diverting water that's supposed to go down into the ground and keep a balance in the substrate moisture. Well, when there's no water down there, the substrate dries up, and then as the earth's moving around, it starts shaking it like a sieve until there's nothing binding it all together. That creates the sinkholes, and houses disappear.
Oh, wow. Yeah, so you were saying it's essentially regular concrete, but you remove the sand out of it, and that creates the voids.
Correct.
Is that okay? And then again, I cheated. I was looking at your website and that document you sent me, but it sounds like the base material as well is different from what we would put down for, like, say, a sidewalk or a driveway or something. Is the design of it's a little bit different than what we would typically do?
It can be. Pervious concrete started in the 80s in Florida, and they put it almost always directly on the sand.
Okay.
The Florida concrete people put together a really nice video showing the rest of the world how they were doing pervious concrete. The first state to adopt it after that was Georgia. And down in South Georgia, they started doing a number of pervious concrete parking lots. Well, all of a sudden, alarm bells started going off because these parking lots, after a rain, were becoming swimming pools. So me and the fellow that was the director of the association down there, we took a trip for over a couple of days, and we went to each and every one of these jobs to look at them. And we found one common denominator: the Georgia red clay.
Mm-hmm.
The sugar sand in Florida will take the water, the red clay will not. And that's where the idea of what we now call a recharge bed was thought of. And so depending on what the soils will take in a perk test now, same test you would do if you want to put in a septic tank, basically. And if the soils will take the water, you're probably all right. One of the very first big jobs we ever did was up in Vermont. Vermont has a lot of harsh winters. And so we didn't know what exactly was going to happen up there. So we did 3 different recharge beds. We did a 12-inch stone recharge bed. We did a 24-inch stone recharge bed. And then we did 5 foot deep, and we put plastic Cultec chambers to capture the water for future use in there. And we fully expected the 12-inch to fail. But we learned it didn't. The 12-inch after 5 years was still as good as everything else. And so we've kind of come to the conclusion that if you have at least 12 inches of stone, which typically has about 40-45% voids in it, it will hold the water long enough to then infiltrate into the ground or be evaporated back up into the atmosphere.
Oh, that's cool. So you're kind of creating a kind of like a French drain almost.
Basically, an underground reservoir, yes.
Yeah.
And even in grounds that are tight that won't take the water, we can then drill some holes down. If you drill down deep enough, you're going to find pockets where water can escape to. So that's another option.
I get you. So the base of the pervious concrete, it depends on where you are, where you're putting it down. So there's not one base. So Florida has something different, Georgia has something different, Vermont had something different. So wherever you're at, you kind of need to get someone like you and say, hey, I want to do something in Virginia. I want to build in Virginia, put down some pervious concrete. I need to get a hold of you and have you design it to make sure I don't do something that worked maybe in another state, won't necessarily work in my locality.
Correct.
Gotcha. And then so we were talking about you have a background in just sound like ready mix plants before. So how did you get involved with pervious concrete, I guess? Why pervious concrete?
Well, when I was in Nashville, we had 2 ready mix operations, and then for lack of a better word, I've always been an early adopter in computers and concrete, and kind of how I made my mark in the ready mix business was you taught me how to batch concrete. You taught Joe how to batch concrete. Well, that wasn't good enough for me. I went and got a book from the manufacturer of the batch computer, and I read everything there was to know about it. So when we started hearing about pervious concrete, it kind of clicked my interest. And then from an association standpoint, when they had problems, well, I offered to go down with Dan Brown and look at these things. And it just dawned on me what a great product this is. I've retired in 2001. I went out to Oregon and retired. And I had a good friend that had a ready mix operation out there. And after a little while, maybe 3 months of being there, I was kind of depressed and realized there's this seasonal disorder where, if you don't get sunshine, you get depressed.
Right.
And so I asked one day, so Rob, how come you guys don't do pervious concrete? What's that? Oh, let's make a sample of this. Let's show you what this stuff is. It is the greatest thing since sliced bread. And so we did that, and we made some samples. We put it into a fish tank. We had a little goldfish floating around in there, and we'd go to architects and engineers' offices. And we actually, one day, we rented out a movie theater. And we did presentations at 9 o'clock, 11 o'clock, 1 o'clock, 3 o'clock, and 5 o'clock, so that no matter what your schedule was, you come see us and learn about pervious concrete. You came in, we gave you a bag of popcorn, and you sat down and you learned about pervious. And so the more I got into it, the more I wanted to get into it.
Okay.
One of the early problems was that people all over the country were going down and taking a Florida mix design. Well, the stone in Florida is different than Oregon stone, which is different than Texas stone, which is different than Minnesota stone. They're all different. They have different properties. Some people in Washington State uses a lot of round pea gravel. Here in Ohio, we have a really nice, 1/4-inch trap rock. So it kind of dawned on us that 600 pounds of cement and 2,700 pounds of stone wasn't going to work everywhere. And so it just thing after thing after thing, we kept stumbling into all these different discoveries. Some of them, the one that really sticks out in my mind is that we made some samples and we did not ask the testing lab to make beams. The guy came out and made beams. Well, he's already halfway through, just let him go ahead and make the beams. And when he pulled the beams, the Pervious looked beautiful. You look at the top of it, I mean, it was just spectacular. But what we noticed was at the bottom of the beam, there was about 1.25 inches of solid paste.
Mm.
So all the cement paste had drained down. There was still enough to glue the stones together, but it sealed the bottom off. Now imagine if you had 500 yards into a concrete parking lot and the whole parking lot was sealed off at the bottom. Somebody was going to be very angry about that.
Right.
So that's when we started adding things like viscosity modifiers in there to hold those fines up in suspension until everything set for us. And we learned that. We learned about hydration stabilizers. The old mix designs would call for you run 2 loads of pervious concrete. Before a third load, you had to send that truck to the batch plant, get loaded up with stone, and beat all the remaining pervious off the drum. And they would use retarders. Well, we accidentally found out that hydration stabilizers were the way to go. And it helped discharge the concrete easier. It kept the trucks much cleaner. And the third benefit was the curing time is so much slower that we actually got much better strengths out of it. And so it kept snowballing like that. How do we make this better? How do we make this better? How do we make this better until we're where we're at today? And there's 3 of us in the country that kind of sing from the same book, and we're all pretty much doing the same thing. And there's slight differences here or there, but all of our Pervious is durable and looks great.
Yeah. So what's the problem that Pervious solves? Like what material is it replacing? Is it replacing asphalt in applications? Where is Pervious, I guess, where does it shine the best?
Well, any application, if we can take market away from asphalt, we're very happy about that. But even in concrete, if we don't have to have concrete parking lots or sidewalks, it's beneficial. There are subdivisions over in Raleigh, North Carolina, where all the homes in the subdivision now have pervious driveways.
Oh, wow.
And that helps, again, keeps the water in that neighborhood rather than going, so the city of Raleigh doesn't have to pay to process that stormwater because it's going into the ground. But it also, I know in my neighborhood, we have some sidewalks that are buckling because of the drought and things like that. Well, it's not such an issue over there because the ground stays moister at a more consistent level than what it does in other areas because they're allowing that rain to go into the ground where Mother Nature wants it to be.
I gotcha. That makes a whole lot of sense. So is there other, like the neighborhood in Raleigh, when you have pervious concrete, does it require the same, I guess, infrastructure as if it was all impervious concrete, like normal concrete? So would you still have curb and gutter and drainage like that, or is there savings on that side too if you use pervious concrete?
There can be. There are places, Washington, D.C., we did a whole lot of alleyways a few years ago. People don't pull up to the front of their house to park in many parts of D.C. They go behind the house through an alleyway. Well, by putting pervious concrete down, they don't have to have those catch basins. Everything goes into the ground. So that's a huge savings. They don't have to build that infrastructure. The ones in Raleigh, they have the streets are regular asphalt streets. And so there are catch basins there to catch the water coming down the street, but they're not carrying extra water from anybody's house.
Mm-hmm.
They'll actually take the roof drains and run them into the recharge bed of the pervious. So nothing from your property runs in the street. It either goes into your grass or down below to the recharge bed.
Gotcha. So sounds like there can be situations for it, but pervious would probably be good where you can't necessarily build that infrastructure as well. Like if there's areas that you can't have the catch basins for some reason, if you're like you were saying, that alleyway, if it wasn't paved before and now you're paving it, it would probably be difficult to put catch basins or stormwater management systems in places. And so maybe pervious concrete could be a solution that would keep that area from flooding or being covered up when you have a torrential rain or something like that.
The key word there is it can be. Most engineers prefer the belt and suspenders approach.
Hmm.
They'll still do both.
Gotcha.
And we've had systems we build with an outflow in case it ever got up that high. Uh, and I've never known a single case where the water ever got up high enough to then go out that outflow, pipe.
Right.
It's what they're used to. They're used to catch basins and sewer systems.
Is there uh is there any reinforcement in pervious concrete? Obviously, you wouldn't have like rebar in there since the water's going through the concrete itself. That would be detrimental to rebar. But I think I saw somewhere that there is sometimes some reinforcement with pervious concrete.
There can be, if you're doing a super heavy duty structure, there is a basalt rebar we could use that works pretty well. You're right. Regular rebar will not. It'll rust over time, and the galvanized is just too expensive. What we have found works the best, what we call quote unquote bulletproof pervious concrete, is Forta has a fiber called Forta Ferro, and they have a hybrid product that's got recycled materials into it. And something about the way that they manufacture it, when it's put into a mixer truck, these strands unwind, and it makes this unbelievably tough pervious concrete. In fact, the job we just came off of in Brooklyn, the testing lab came back to me and said, Bob, is there any way you can change the specs or write a letter where we don't have to do any more core testing? I asked why. And said, you will not believe how long it took us to get cores out of your stupid pervious concrete. This stuff is tough.
Huh.
So the procedures we use, the materials we use, and this one particular fiber, and again, we've tried a number of different fiber brands to it, and this one just has the best results of anything we've ever done.
Wow. You wouldn't think that since it's porous, right? So you wouldn't think it would be that strong. So what kind of strengths do you see? Do you see the same strengths as you do with traditional concrete?
Yes, but we don't publicize that. There are no ASTM standards for testing pervious concrete for strength.
Gotcha.
We on our own will have cylinders made using the same procedures we use when we do a unit weight test. And we've seen our strengths come up tremendously, and we know what the flex strengths are. And on a pavement, that's really what we're concerned about anyway, is the flex strength.
Hmm.
But no fiber versus fiber, we get much better results. And in typical concrete, you'll never hear that. No fiber manufacturer in the world will tell you they increase PSI using the fibers. But again, pervious concrete is different.
Hmm.
Still concrete, but it's different, and it does get benefits strength-wise and flexibility-wise.
Huh. That's interesting. And then as far as we were talking before we got started, you were saying um, you were seeing issues throughout, not throughout the country, but with different ready-mix suppliers that were trying to produce pervious concrete, and you were seeing that maybe they were doing something or another and were not producing a good product. What are some, I guess, typical issues that you see um, on jobs that pervious might have been the answer if it was produced correctly? What are some issues that you see in your day-to-day work?
The number one biggest thing you'll see almost immediately is what we call raveling. And basically, a single stone becomes dislodged. And then as people drive over it, it acts like sandpaper and it dislodges the next stone. Those two stones then dislodge 10 stones, which then dislodge 100 stones. And just the mix wasn't tight enough. Early on, people, and ourselves included, we tried to treat it like regular concrete. In our minds, the lower the water cement ratio, the stronger the concrete, which we found out was absolutely opposite of it. So we would see mixes with a 0.27 water cement ratio, maybe a 0.30. But we learned over time that they were actually being starved for water. The cement wasn't being fully utilized. Most producers have a 3/8 inch stone in their stockpiles. That's what they blend with their 57 stones, because the asphalt people take out the good small stones to produce asphalt. So then the concrete people have to blend things back together to make a better stone. Well, first of all, 3/8 stone kind of makes an ugly pervious concrete. Women don't like to walk on it because the stones are too large. But the biggest thing is that the stone is normally dirty. If you go to a concrete plant, go to their stockpile and grab a handful of stone and shake it in your hands, you'll come away with dust all over your hands. Now, if you and I are building a regular driveway, that's going to make extra paste. It finishes nicer. We like that. But we found out that that dust is what caused the problem with the beams that we had cast, created that paste drain down. So now we look for what's used to make asphalt. For asphalt bitumen to bind to a stone, that stone's got to be clean. Clean enough where I can pick up 2 or 3 pieces, put in my mouth, and I cannot create a paste. It's that clean. Typically, they'll have anywhere from a 40 to 46% void content into it, which is very clean. And we can make really good pervious concrete if we find and source the proper stone. The other problem we had early on was that everybody was going off these 600-pound Florida mixes. And through the Chinese Olympics, we learned that only about 55% of that cement in that mix was ever being hydrated. If the cement doesn't get hydrated because of a lack of water, it can't do its job. Therefore, we had some really low-strength pervious concrete. And then a fellow named Dale Fisher had come up with what's called a super absorbent polymer that we started adding to the pervious concrete. And what that does is that it goes into the mix and it absorbs extra water. So overnight, we went from a 0.30 to a 0.3739 water cement ratio. And this super absorbent polymer will grab that extra water, turn it into a gel, and basically hide it from the cement. As the cement's doing its thing and hydrating, and it runs through the batch water, it's looking around, it's still thirsty, and it sees us hiding water from it. So its affinity or desire to have more water given to it is stronger than the super absorbent polymer, which then releases that water to it. So we get a more complete hydration. So now we're pushing 96, 97% hydration on the cement. The other benefit to that is where concrete used to be very slow coming out of the trucks, we can discharge 10 yards of pervious in about 10 minutes. If we're doing a large job going through a conveyor belt, we can dump 2 trucks in at a time. And in 15 minutes, you've got 20 yards of concrete on the ground. Where it used to be 10 yards would take us an hour and 10 minutes maybe. So there's benefits. It's all, the mix is everything. There's no way to shortchange. If you get the pervious mix right, it's hard to mess it up.
So it sounds like there's quite a bit of chemical use with pervious. Is that a fair assumption?
Not really. Well, the super absorbent polymer, which comes in a bag form, we throw it up into the truck. But the other key thing, we use a high dosage of what's called a hydration stabilizer. People will know it as either Delvo or Secatard 440 or Recover. Most admix sales guys almost have a heart attack when I tell them the dosage rate I'm running. In regular concrete, they might run 1 to 3 ounces a hundredweight. Well, we start at 12 ounces a hundredweight, and we may go up as high as 20 ounces a hundredweight, always based on ambient temperature and how far we're traveling. And basically, it puts that cement to sleep for a little while. The old way of doing pervious concrete, you had to get it down on the ground, finished, and covered up with plastic within 20 minutes. And we sat out there with stopwatches. And if you were at 19 minutes, we started screaming at you, get it covered up, get it covered up, get it covered up. By using these high dosages of hydration stabilizers, it can be out there for 2.5, 3 hours. If your plant breaks down, or a truck gets a flat tire, and a truck doesn't get to us for 30 minutes, it's no big deal. We just pull a piece of burlap over the edge of it, wait for the next truck to come in, chop it and blend it in. You'll never see a cool joint. So from a finishing standpoint and from the contractors, it can be a lifesaver. And so those are two, the internal curing through the SAP and the hydration stabilizer are really the only 2 chemicals we use in the concrete.
And then, so we talked about the producing pervious concrete and the issues there. Is there, I guess we could start with is, as far as placing it, what's the difference between placing pervious versus normal concrete?
With our mixes, really, there's not much difference. Of course, you cannot pump it, and there's not enough paste to pump it. We prefer to use a conveyor belt if we're on a big job, simply so that the trucks don't rut up the recharge bed. So we can go into Georgia buggies. We come directly off the back of the truck through the chutes. The job over in Brooklyn, we were very tight on space, so they actually went into a bucket, and then the backhoe swung the bucket in position. But the the finishing procedures, once we get on the ground, are quite different. We will first use a roller screed. We use the Lure Lightning Strike. It's made out of aluminum. And the nice thing about their system is it's adjustable. I can go from making a 10-foot wide section to 15, 16, 17, whatever I want to in a matter of about 3 minutes. Their poles screw together. And the tolerances are so tight that they can actually do regular concrete with them and get really good F numbers. But that's what we call the initial compaction. We screed, get it down, and then we take a cross roller that weighs about 55 pounds, and we'll cross roll it perpendicular. And that's our secondary compaction. And then what we've learned with that is there's a product called single seal that we spray onto the cross roller. We used to use bubblegum release, and again, accidentally, we found out that the single seal really helped it. So we spray it onto the roller to keep the stones from being picked up as it rolls back and forth. And then once we do all that, we wait a little bit and we put a pizza pan trowel machine on it. People have never seen trowel machines put on pervious concrete before, and most guys think we're insane, but when we show them how well it works, it basically is basically making a like a puzzle, a jigsaw puzzle. It locks those pieces of aggregate down flat. And the locking in procedure is so good that we very seldom see raveling because of that. And then we'll spray the whole surface over the top again with this single seal. So we don't have to use poly, which can be a bear. You're going to have 4 guys on your crew just dedicated to putting polyethylene curing onto the pervious concrete. So those 4 guys are now freed up doing something else. And then you're not having to take that poly when you're done and put it in the landfill, which environmentally is a good thing. But the biggest thing is it has a densifier built into it. So we densify, cure, and seal it all in one procedure. Going back to the earlier comment about the testing lab begging us not to make them do any more cores, what we found out through petrographic analysis was that initial spraying on the cross roller, some of that material ran down what we call interconnected voids and strengthened that paste. The bond from the paste to the stone became exponentially higher. And so the use of the fortifibers, ferrogreen fibers, the single seal, and then the spray curing of it, it truly is bulletproof pervious concrete.
And for folks that don't know, the petrograph that's when they take the small cores and then they slice them, right? And then look under
a micron microscope.
Cool. So sounds like the screed is different because typically the normal traditional concrete use a flat screed, and you're saying the screed you use for pervious is actually a rolling machine kind of.
Correct. And being made out of aluminum, it'll actually cut the concrete down. We can make fewer passes on it. You know, if you go over too much, you might actually seal it. But with our mix designs, they're so well balanced. We used to hear a lot and used to go to a lot of job sites where people would say the concrete was too wet, where there were big wet spots. They weren't wet spots. They were spots that had too much cement in it. And when they finished them, they smeared the cement and created what they thought was a wet spot. But again, at 600 pounds of cement, there was just too much cement in there to do its job. We're down normally 515, 520 pounds of cement. So if you're saving 80 pounds of cement on a mix, and the theory is if you take a handful and smash the pervious concrete as hard as you want to, you should not be able to seal it up. It's all about having a well-balanced mix design.
Yeah. So those folks that want to be green and in construction, you just heard it from Bob that there's less cement in pervious concrete versus normal concrete. Did I hear that right?
No, that's true. We can also use fly ash. And we really like to use slag, which is a byproduct of the steel industry. So anything we do to lessen the cement content in the mix is always a good thing in the concrete industry these days.
Yeah, there's loads and loads of, I'm looking out my window now, there's all kinds of sidewalks out there that we could have replaced with some pervious concrete. We probably saved loads of cement and cost but like I told you before, Bob, before I reached out to you, I'd never ran across pervious concrete before. And why do you think that is? Why don't we hear more about pervious concrete?
Well, it's gotten a really bad black eye for just honestly too many failures around the country. Certifying people that then went out and did jobs that they didn't know anything about. I mean, I could put you through a class and that doesn't tell you anything. When we teach a certification class, we teach the class first, so that then when we're on the job site, I would come to you and say, Seth, give me your foreman. I want him attached to my hip. Everywhere I go, I want him with me. I start every single day at the batch plant. I look at their stone piles, make sure that there's no contamination in there, because I've caught contamination in the stone piles before. And then I show him the procedure for putting these, how do I want the fibers put into the truck? When do I want the SAP put into the truck? Then we go back to the job site. And as we're going along, I'll start running the roller screed. And I'll say, Seth, come take the roller screed. And if you're going too fast or too slow, we'll make small corrections. And we purposely move everybody on the crew around to all these different positions, so that, by the end of the first day, which is always a cluster, nobody knows what they're doing. But by the end of the first day, they start to gel as a team. Everybody starts to realize what their position with doing pervious concrete is. And the goal is to do it after 2 jobs, because most specifications call for, to move up to an installer level, you have to have 3 jobs under your belt with over 10,000 square feet. And so my job in life is to get those guys as qualified as possible, as soon as possible, so that by the 3rd job, they don't need me. If I'm there on the 3rd job, I'm simply watching, taking pictures, videotaping, but all the corrections and the teaching moments have come in the first 2 jobs.
Yeah.
So if we can do that, we can, change the favorability of pervious concrete. Again, the job up in New York City went real well. They will be specifying more. They just need to know how to do it properly, and that truly is the hardest thing. There's people out here who say they're craftsmen, but in my mind, if you're a craftsman and you've got that much experience under your belt, you need to be adopting the latest methods and materials. You need to know how to use a trowel machine. If you're going along and something changes in the mix, you've got to be able to diagnose it quickly. Something else we do different than most guys, we test every single truck as it comes to the job site before we put it onto the ground. We did a job up in Hartford, Connecticut about 9 or 10 years ago, and we got halfway through the job. There was a hurricane blowing in. So they buttoned everything up tight, covered everything up good. We went away for the weekend, came back on Monday, and the first concrete truck showed up, and he was too heavy. The unit weights were way out of whack. And so the second truck showed up. He was heavy also. I called the batch plant. I asked, where's your moisture content on your stone set? He asked, why? I said, because I think it's where it was set last week. And he said, well, yeah, we run to 0 all the time. I said, all right, stay with me on this. If you were at 0% moisture last week and you got 12 inches of rain on your stockpiles overnight, how can the stone still be 0% moisture? Oh. So they had 4 loads of Pervious already on the way to us that we rejected, sent back to them. And so he made the changes in the computer, took the extra water out, put the extra stone in like he should have, and everything fell right into line. But imagine if we put down 40 yards of pervious concrete and then find out 2 months later it was not pervious.
Mm-hmm.
That would have been bad for everybody. So it's much easier. It takes us 3 minutes to test a load of pervious concrete doing a unit weight test. And that's once we know what the unit weight test is, and just to pick a number, say it's 125 pounds a cubic foot, and the next one comes in 125.1, 124.9. As long as we're very close, we're comfortable. Pour out the pervious concrete. But if it came in at 127, 128, we would stop, do the test again, and different specifications have different levels. Most specs will call for plus or minus 5 pounds a cubic foot. Our specs call for plus or minus 3, because if you think of it, 10 pounds is a huge difference. If you're 120 versus 130, there's a visible difference to the pervious concrete. So we've tried to tighten that window up. The job in New York City that we did in Brooklyn, the batchman was so good, and he and I talked on every single load. It didn't matter what I asked him, he did it, and it was spectacular. He was plus or minus 0.34 over the entire job, which is pretty doggone good.
Yeah.
So he got a nice steak dinner out of me for that one.
So is that unit weight the only thing you test then?
Yes, that's the only accepted weight for acceptance pervious concrete. Now we can do a test later for infiltration rates, and some people specify that, and they'll pick a number up out of their head. But I've never seen any pervious that would not easily meet any specification out there as far as infiltration goes.
Gotcha. Well, good. Well, I think this is a good spot to stop for today, Bob. And hopefully we get the word out there about Pervious concrete, and folks can start thinking about it's where can we use it, and good applications for it. If it obviously, if like Bob shared with us today, we're doing the quality control that we need to do on it. Bob, if folks want to reach out to you and learn more about Pervious concrete, what's the best way?
Easiest way is just to visit our website, pervious.us.
Okay, and then there's contact information on there, and I will put that in the show notes for everybody. Bob, thank you again for coming on, and we'll have to do it again. Make sure we get the Pervious concrete word out there.
Be happy to anytime. Thanks for calling me and involving me in this project.
Yes, sir. Thanks, Bob.
All right, have a good day, Seth.
Thank you for listening to another episode of the Concrete Logic Podcast. If you like what you heard and you think others would get some kind of value out of this podcast, please share it with them. If you have any ideas or topics that you'd like us to discuss on the Concrete Logic Podcast, you can email me at seth@concretelogicpodcast.com or hit me up on LinkedIn. Pretty active there. Again, thanks for listening, and we'll see you next time.